Good afternoon. Welcome to our session on Smart and FHIR. Josh Mandel presenting. First one after a break, not after lunch at least.
That's right. Okay. Hopefully folks have gotten caffeinated. Everybody's made their way upstairs to the Bright Lab. So welcome to day one of DevDays. I want to start off just by showing you my final slide here, which is the feedback request slide. I really would appreciate if folks have a chance to provide feedback on this session. I've been doing similar sessions for a while, and there's no better way to sort of tweak and orient than real feedback. So I'll share this link again at the end of the session. Please do take the time if you can to give me some feedback on this one. All right, a couple other bookkeeping notes. The slide deck that I'm going to show you here is also available at bit.ly/smartfiretech. And that page actually has a whole list of different slide decks along related topics, many of which will be represented at DevDays this week. And during this talk, I will also include pointers to some of those topics. So I might just say a couple sentences about something like FHIR bulk data or clinical decision support hooks as kind of pieces of this ecosystem that work with and connect in with Smart. But those will be also forward pointers for you to learn more here at DevDays or online. All right, so I should introduce myself briefly. I'm Josh Mandel. I'm a physician and software engineer, really focused on health data interoperability. And I lead a small team at Microsoft Research that is focused on our work with the FHIR community and with HL7 more broadly. And I'm also the architect for this smart health IT project that I've been working on kind of since 2010, ever since I graduated from medical school. And just to give you a little bit of background on the SMART project, SMART is actually an acronym, and it stands for Substitutable Medical Applications and Reusable Technologies. But the idea here was this is a grant that was originally funded in the US by the National Coordinator for Health IT. And it was kind of an investment in future technology back in 2010 when the federal government in the US was also investing in adoption of EHRs. So there was this kind of two-pronged strategy of really promoting the adoption of then current technology, but also looking ahead and saying, what kinds of interfaces do we want to make EHRs more flexible and more modular? And over the course of this project, I've had the good fortune to be able to work with many folks from the electronic health record community, software developers and clinical app developers, as well as the standards world. And it's been kind of a wild journey to see adoption. And we'll touch on this a little bit. But over the course of this project, we've gotten to sort of peel back the layers of this onion. What does it take to build an app platform? What are the underlying capabilities that you need in order to do this robustly across different kinds of healthcare institutions? And then what can you build on top, or what do you build next to those apps in order to provide workflows and connectivity within the health system? In many ways, that's kind of the story of SMART, but I want to start by building up from a very simple example. This came from a report that we did about 6 years ago, talking to clinical provider organizations, trying to understand their pain points in integrating different technologies into their clinical workflow. And here was one quote that we heard from that community. It's just an example, but I think it speaks to many other similar examples where this was a health system that had a wonderful population health tool, but they couldn't get data from the EHR to interface with that tool. And they had to do a lot of data entry by hand, kind of manual synchronization. And eventually they gave up on this tool because it was too hard to keep up with that level of manual effort. And so in a sense, that is the core problem that we're trying to address with the Smart Health IT project. On the one hand, we've got a whole variety of different healthcare applications and services that may be focused on doing a very narrow job. And I'll show you examples of some in the course of today's presentation. And on the other side, we've got many different kinds of clinical systems that were designed by different teams for different purposes at different levels of scale. So this could be an electronic health record system that clinicians use day in and day out at a hospital or an ambulatory practice. It could be a patient portal that provides access to patients to their own records. It could be a clinical data warehouse that's used for research. The sorts of data that an app like this might want can live in many different kinds of systems. And so the goal for Smart has been to create this kind of interface in the middle where we focus on a few core aspects of what these apps need. So first of all, there's the sort of user experience integration. This is particularly important for apps that are integrating into an EHR. For a clinician who's going to be running an app during the course of their everyday work, providing care, they're not interested in leaving the EHR and signing into a different system and selecting a patient from scratch. The user experience of that app really needs to be integrated and automated into the EHR experience. So that can be really important for some use cases. Of course, we have aspects of security. So authorization. How do we make sure that apps can get access to the data that they're supposed to have and not access data they're not supposed to have? And single sign-on. So some apps don't care at all about who the user is at the keyboard. Maybe all your app cares about is, can it get an access token that's going to be able to fetch data about the patient and calculate a risk score? So that's an example of an app where it doesn't matter who's using it. It's always going to do the same job. But other applications care a lot about the user. Maybe they're just customizing the UX based on the user or that user's preferences, or maybe they're even implementing access control patterns. So one thing you can do with an app is provide access to external data. Maybe you're building a system that helps a clinician see what medication prescriptions the patient may have received from outside of this facility. And before you go and query that external database, you need to be sure that you've got a user who's authorized to see those data. So single sign-on can be very helpful for those kinds of scenarios. And of course, the most important aspect of a platform like this, but the one that I will touch on the least because we're here at FHIR DevDays, is the actual clinical data APIs. And for now, I'll just say we use FHIR, and there may be profiles on top of FHIR that tie into national or regional schemes. But we try to say as little as we can about those profiles at the level of the SMART implementation guide, because SMART is focused on what we call in HL7 the universal realm. So we really try to describe the details that won't vary from place to place. So what is the point of having a platform like this? It depends on your perspective. If you're an end user, which could be a clinician or patient or hospital administrator, the idea here is you get your choice of apps. And so if there's a better app for managing hypertension that comes along next month, you want to be able to try that app out in your workflow without giving up on all the data that you've been storing and all the patient records that you've been managing. You should be able to switch apps without switching everything under the hood. And from a software developer's perspective, this kind of platform gives you a kind of low barrier to entry. You can build your app once and integrate it inside of a standardized clinical system, and then that app is portable. You can take it and integrate it with another EHR vendor or another customer site. And I should put an asterisk here, because what we aim for is this kind of plug-and-play reusability, but there's a lot of complexity to that process, and there are some trade-offs from an app developer's perspective. And so realistically, when I think about the value proposition for this kind of platform, it's chipping away at all the custom integration. I don't want to come up here and say, if you build an app using Smart, it will plug and play everywhere. I think that's a false promise for any kind of platform, but I do think it gets us closer to that ideal. And that's a theme that I'll try to highlight during the talk when we think about different FHIR libraries and different sandboxes for testing the apps that you're building. To keep in mind early on that there are ways for apps to be more brittle or ways for apps to be more robust, and think about that kind of robustness from the very beginning. But from an app developer's perspective then, these EHRs become kind of a platform, and they handle platform considerations. So just like on your mobile phone, your OS might manage your contacts for you. In this world, the EHR manages users and patients and handles core workflows, it handles data persistence, and applications have access to query the data under the hood, but they don't necessarily own or manage that data. So just the same way you could switch out a calendaring app without accidentally deleting all of your appointments and having to start from scratch, we should be able to do the same kind of thing with clinical applications. And I just want to say a couple of things about adoption, both in the US and more broadly. These are technologies that are being widely implemented by many software vendors for health record technology. In the US, this is actually part of a national certified health IT program. So as of the beginning of this year, 2023, every certified EHR in the US needs to have support for these Smart on FHIR APIs, providing access to kind of a core data set. So in the US context, we say that's the US core data set, and there are US-specific profiles that get into how do you model medications and encounters and allergies and so on. So we say US-relevant things about what vocabularies and coding systems to use in those US core profiles. But more broadly, what's happening at the international level, and this is a set of topics that's worth following at DevDays, I think, is the emergence of this IPA, or International Patient Access Guide. that is developing, again, using the smart approach to authorization and data access, but in a more generic way, to say plugging into that platform could be profiles that make sense in a specific country or region. So in the US, I just want to hold this out as kind of an example. The adoption curve can be pretty slow, particularly for developers who are used to fields outside of healthcare. So for a healthcare perspective, this is like we started working on this spec, let's say 2014 or 2015. We had some early prototype implementations, 2015, 2016. And then regulations were published back in 2020 saying, starting in 2023, this is functionality that's going to be required in EHRs. So we're talking about kind of 8 years from inception and prototypes to the point at which regulations can lock in requirements. And I just want to use this as a benchmark for kind of a realistic or maybe even aggressive timetable. This is not lightning fast stuff, but it's the kind of investment that we can make as a community, and the power of starting early and building on top of proven technologies and integrations is that over time, we can start to get this kind of robust ecosystem. So I want to drill in and really familiar for anybody who knows kind of an OAuth workflow. The smart specification is based on OAuth 2, and it has a client and kind of a server. And the goal that the client has is to get authorized by a user to access data on the server. So that's kind of the game that we're playing. And in Smart, we specify on top of OAuth a few details that we lock in about that protocol. So anybody who's worked with OAuth will know it's a little bit like FHIR. It's kind of a framework for protocols with a lot of flexibility, a lot of knobs and dials you can turn. And to make use of it successfully, you need to make some decisions ahead of time. And that's something we try to do in this Smart implementation guide, is lock down exactly what flavors and options of OAuth we're using. So from an applications perspective, there's basically 2 ways an app can launch into an EHR. I'm going to start with the simplest one, which we call the standalone app launch. And the use case here is you've got an end user who is going to begin by launching the app from scratch. So maybe you're a patient and you've got an iPhone and you're going to launch the Apple Health Records app on your phone, and that's how you're going to start your session. That would be an example of a standalone launch, because first you launch the app, and then having launched the app, you'll connect it to the EHR. And so the basic flow here is the app is launched by the user, and the patient, or the end user I should say, is going to do something to select what server they want to connect with. So in the case of patient access, often what will happen is the app will display kind of a selection process. They'll say, are you trying to get access to your own records? What state or jurisdiction are those records in? And you'll drill down and you'll find your healthcare provider and you'll say, yes, I want to connect to the Unity Point, Wisconsin FHIR endpoint. Typically, we won't put the word FHIR in front of patients, but we'll try to show the names and logos of their healthcare provider organization so they can recognize what it is they want to connect to. And then the app begins by sending an authorization request that basically opens a browser window or browser context into the EHR's authorization server. And if a patient or the user isn't signed into that portal, they'll be asked to sign in. And then once they're signed in, they'll be asked to make some decisions. So at a high level, they're going to say, yes, I want to approve this app. I want it to launch. And then they may be able to provide additional details about what kind of data they are comfortable sharing with the app. And that will control, ultimately, what the app is able to query. So that's this kind of authorization request and authorization response. And once the app receives the authorization response, assuming it has been given the thumbs up to go ahead, it can then request an access token from the EHR. And this happens automatically. This is a direct connection over an HTTP request. So the app sends along an authorization code, and the EHR responds with an access token. And a few other details. How long is the access token going to last? What scopes or data permissions is it associated with? And the app can use that access token then to fetch data for as long as the access token remains valid. So that's the basic workflow, and this is specified for apps that participate in this standalone launch. Start from the app, then connect to the EHR. We also have a variation on this workflow, which we call our EHR app launch. And it's just like the last one we saw, with this step 0 right in front. So the use case here is you've got a clinician who's inside of their EHR. They're working with their system of record. They open a patient record inside of their EHR, and now they want to launch an app. Maybe that app is mapped into a particular menu item or tab of the EHR. Maybe the EHR is pre-configured to always open a certain app when you start with a new patient. And as soon as that app is launched, the way that it happens is the EHR opens a new browser context onto the app. And then the app proceeds to go through all the steps we've already talked about. So it's very much the same flow, but it begins with this step where the EHR is responsible for deciding when to launch the app, what portion of screen real estate to give to the app, and so on. So that the user experience here is to see the app embedded in the real estate of the EHR. Let me just pause here for a second. I've been sort of sharing a lot of details about this back and forth OAuth dance and a little bit of background. Let me just see if there's questions from folks in the room on anything I've said so far, clarifications. Yeah, please.
I guess it's actually for this launch request. So if you're launching from the EHR, is there a reason to do the authorization and token because you're launching from inside the EHR?
Yeah. So if you're launching from the EHR using this flow that's on the screen right now, is it really necessary to have kind of all these steps? The app is in some sense maybe pre-approved. The user doesn't need to be involved and click a button and so forth. So what we've tried to do with this design is make it so that this example can be streamlined, but the protocol doesn't change. So in some cases, the EHR click here to continue. That's actually pretty rare. Mostly what happens is that decision gets made by the organization when they first decide to adopt an app, and then at runtime, nothing is displayed, and it's just sort of automatically processed. But at the protocol level, we try not to be opinionated about that, so we have this sequence of steps that's consistent, even if some of these, like the approval of an authorization request, are implemented to be automatic from the user's perspective. Yeah. Any other quick questions or clarifications from this content so far?
What is the launch ID? It's not used anymore in the sequence diagram.
So thank you. Great question. And good reading. I wrote sort of this launch ID as this special thing that the EHR passes to the app when it decides to do this EHR-based launch. So the launch ID is an opaque token from the app's perspective. It's a URL parameter that gets sent into the app, and the app actually includes it here in step 1. This should say scopes, comma, launch ID. So I will update this slide after the presentation, but the app doesn't understand that launch ID at all. It just ties the session together, and it makes sure that when the app eventually is launched, it can learn details of the context. So namely, what patient record is open in the EHR right now. That launch ID is a parameter that gets threaded through the request so that at this access token response, the app can learn what is the context of the EHR session in which it's being launched. Great question. Anything else before we dive ahead? Yeah.
Hi, I haven't fully understood where Smart is here. So Smart is the protocol, or is it an endpoint you install or integrate into the app or in the EHR, like a plugin, or?
Yeah.
So what is this from a technical perspective?
Yeah, it's a great question. From a technical perspective, I've said Smart is a project, and we have these lofty goals, and we have this architectural approach. From a technical perspective, Smart is an implementation guide that's published through HL7's Universal Realm, and it describes all of the bits and pieces that I'm talking about here. So it describes how that launch flow works, which OAuth profiles and protocols and parameters to use. And so this Smart implementation guide takes you through the details of the requests and the responses. It tells you which parameters are optional and required, and it describes how clients can authenticate. It's sort of that set of capabilities, and a few more things that we'll talk about as we go on. Yeah, for sure. All right, so let me talk about permissions. When an app launches, it includes a standard OAuth parameter called scopes. And this is basically a way to communicate to the health data system. Here's the kind of data I need access to. And in Smart, these scopes have kind of 3 parts. In the OAuth spec, generically, scopes are just anything you can put in a string that doesn't have spaces. And if you want to combine scopes, you put them in a string with spaces in between. So OAuth does not have very much to say at all about how to model permissions, but it's kind of a flexible toolkit. And so in Smart, we say our scopes will look like this. There's always going to be an access type, and so we call it a patient type scope. if we're talking about data that's going to be about the one patient that is in context when the app launches. So a lot of apps run on one patient record at a time, and it's great if you can scope down their access to just that patient. Now, the app doesn't know what patient it's going to be working on. It might be launched 50 times over the course of a day, each time with a different patient. So the app can't say, I need immunizations about patient 1, 2, 3. It doesn't know the patient. That's context. But it can say, I need scopes about the current patient. What data type do I need? I need immunizations. And then what permissions do I need? This is modeled after the FHIR REST API, CRUDs, so create, read, update, delete, and search. And so by combining these three details, the app can construct a scope saying what kind of data they need. So just to give you a couple of examples, a simple app that is plotting blood pressure results might ask for a scope like this, which says, I need to be able to read patient demographics about the current patient, and I need to be able to read observations about the current patient. That's where blood pressures will show up. A more complex app might be doing read access to many kinds of data. Or maybe you would have an electronic prescribing app that needs to be able to write medication order, or I should say in the most current version of FHIR, medication request resources. And I also want to say that one of the improvements that we've made to SMART in the most recent published version, which is version 2, is to include more specific scopes. So rather than just saying, I want to be able to read all observations associated with this patient, now we can say things like, I want to be able to read all observations where the category is vital signs. So we use the FHIR search parameter syntax to be able to narrow down the scopes of what's being requested. And that's the goal was to leverage existing semantics from FHIR to help apps be more specific and to request kind of the narrowest data set that could work for them. All right, so let me say a few things about the ecosystem and tools. So one thing that we offer from the Smart Health IT project is a public gallery. So this lives at apps.phir.org. And the idea here is it's just a place where you can go to list your app if you're an app developer, or just discover what's out there if you are an end user. And it's very much an open system. There's no fees to list an app here. It includes some apps that are open source. It includes some apps that are commercially licensed. But one of the things that I think is kind of the most interesting about the app launcher is that about the app gallery, is that it supports a built-in preview tool. So I'll show you an example of an app that was developed by Intermountain Healthcare. I think it's a good example because it also highlights sometimes an app can do one really small job, but doing it well is incredibly useful in a clinical setting. So here's an app that was developed by the neonatologists at Intermountain Healthcare, looking to make it easier to take care of newborns who have elevated bilirubin. And there's all kinds of clinical guidelines about how to manage this condition. You might want to treat things with lights, or you might need to do more intensive therapy, depending on the details. And so just to show you an example of what this looks like, the app can query patient demographics to learn exactly when a newborn was born. And then it can query observations to fetch all of the bilirubin results that are available from the EHR. And so this table, in some sense, represents the data as they're stored in the EHR. We did a reading at this point, and we had a value of 7. And we did the reading at this point, and we had a value of 9.7. And historically, clinicians would read these values from a table, and then they would pull out maybe a nomogram, which is like a little visual paper-based tool to sort of plot those points. And it's a very tedious process, and it's error-prone. Being able to display these things in context matters a lot, and the curves are quite sensitive to age. So the x-axis here is how many hours old is that newborn baby, and you can see the acceptable ranges change quite a bit between 0 and 24 hours of age, and then begin to flatten out over time. So this is an example of a tool that can provide very helpful guidance that's much harder to see from reading these raw tables alone. And I show it to you, first of all, because it shows you what a narrowly scoped app could do and how it might be clinically useful, but also just as an example of the Smart App Gallery, it incorporates this Try App button so that as a developer, you can set up your app to demonstrate what it does using patient records that are available through a Smart Sandbox environment. And I'll say a little bit more about that Sandbox environment in a moment. But as an app developer, you can list what you've built, you can include links to screenshots and videos, and you can categorize it, saying who are the users, what does it do, and you can also say what EHRs is it integrated with? So that's just a little bit about the gallery. We've seen kind of a demo that focuses on a couple of these apps. But from the app developer's perspective, so far I've talked exclusively about applications where there is an end user at the keyboard, signing in, launching patient records, making decisions. And that does represent a lot of use cases, but it is by no means everything. We have a lot of examples in healthcare where what you'd really like to do is integrate an app that's always listening for new lab results and maybe firing off alerts in the background when it sees something unusual. Or maybe you're building an app that's going to make a big chart on a computer screen in a hospital ward to show something about caseload or acuity. And there's no user sitting there at the keyboard. It's just a visualization that's sitting on the hospital ward. How can you build an app like that when there's no user in the loop? So in Smart, we have support for this. We call them back-end services rather than apps to try to make a technical distinction between how they work. And those back-end services can be connected to an EHR, and they can use scopes just the same way that user-facing apps can use scopes. But rather than using scopes like all data about a certain patient, for these back-end services, we use apps where the system level, and it will be requesting permissions associated with this system access type. These apps authenticate to the EHR each time they need an access token, and there's an automated workflow for responding to that request with a token. So it uses another flavor of an OAuth workflow, which is called a client credentials flow. And that's also something that we specify in Smart, describing exactly what parameters are used to make that request. One of the important use cases for these kinds of backend services is applications that are going to be doing analysis at the population level. So that's something we call FHIR bulk data access. It's not the only thing that backend services can do, but it's certainly one important use case. And if you want more detail on that, there are a few sessions at DevDays on FHIR bulk data access. So I just want to highlight those. Another interesting thing that happens in an ecosystem where there's lots of apps available and being deployed inside of an EHR is you start to get these higher level challenges. Maybe I've got 20 apps at my health institution, some of which are really useful for a very small number of patients. So that bilirubin app might be a great example. Very useful for newborn children with high bilirubin, not at all useful for anyone else. And at some point, if there's enough apps around in this ecosystem, it can be difficult for clinicians to keep all of those in their head and just sort of choose the right app at the right time. And so one of the techniques that we've introduced is something called clinical decision support hooks. The idea that as an end user is navigating through the EHR, opening new patient records, prescribing medications, and so on, there might be points in that workflow where it's relevant to suggest specific apps. So you might say, okay, based on the fact that you just opened this new patient record and that it's a newborn baby with these certain lab results, we might suggest, here's an app you want to run right now for managing bilirubin. So that's an example of something that can be done with clinical decision support hooks. And there are some other capabilities here as well that I won't do justice in my brief summary, but I'll say if you want to learn more about how an external service can learn about these events, can learn about when patient records are opened or when prescriptions are actively being ordered, that's something you can learn more about in CDS hooks sessions here at DevDays. I mentioned bulk data already. I won't focus on it today, but I'll say for use cases here, there's really a lot. Any kind of application that's trying to learn from a rich set of data at the population level, or manage things like eligibility for disease management programs. So maybe you're launching a new program in a health system for managing hypertensive patients. You want to institute new blood pressure control methods. Well, one thing you might want to do there is figure out which patients are candidates for this kind of app. Who might you want to enroll in the program? And so an app that does a bulk data query would be able to run those kinds of algorithms and figure out who's a candidate for that kind of program. I'll say in the context of the US, I mentioned that we've got support in our regulations for Smart on FHIR, and it applies to what's called a US core data set. Medications, problems, allergies, labs, all the common stuff, as well as common types of clinical notes. But we also know that this is not everything in the EHR. And how do you deal with this gap? As an app developer, you've got kind of an easy on-ramp to the common stuff, What about other things that might not be mapped into FHIR at all today, or that might be mapped into FHIR but mapped differently by different health systems or different EHR vendors? This is a really challenging problem, and it's also a moving target. Like every year, clinical science advances. There's new kinds of data that are important to track. There's new kinds of tests that are being invented, and the standards process moves at a certain pace. So it's not like we're ever going to catch up and finally finish standardizing everything, because the target is moving as we go forward. So at least in the US, we have this concept called EHI export, which is a complement to all these Smart on FHIR APIs. And the regulations here really leave things quite open-ended. But they say, yes, you have to offer Smart on FHIR APIs for the core data set, but there also needs to be some way to export everything else. And we're right now going to be in quite a Wild West kind of phase where each vendor is making its own decisions about how to do this export. And the only real requirement is that the export needs to be computable. So you can't take data that used to be structured in your database and sort of turn them into a JPEG and call that your export. You need to maintain structure. And then you also need to publicly and openly document that structure so that a software developer reading your documentation would be able to work with the data. So I just want to call that out because there are limits to the capabilities that we can get through these standardized APIs, and it's often important to have a broader view to the rest of the data. I'll say from the smart health IT perspective, one of the things that we've tried to do is produce some documentation that links to core concepts for app developers. So deep links into things like the smart implementation guide or the CDS hook specification, as well as tutorials that app developers might want to start with as you're first learning about how to work with these, and software libraries. So there's a resource here at docs.smarthealthit.org, which can be a good starting point if you just want to take a survey of the field. And I'll include a few more slides in this deck that make reference to the content on that documentation site. From a developer's perspective, when you're getting started building a smart app, you're typically going to connect your app to some kind of sandbox environment, some kind of server that's got sample data loaded, and you'll want to be able to test out your app with that sandbox. And there are many available, and it's worth testing your app with many different sandboxes early and often. So I'll highlight one, which is the Smart on FHIR sandbox. It's hosted by Boston Children's Hospital, and it's a happy FHIR server. It's got about 1,000 synthetic patients loaded into it. It also has some sample data resources available there in the mix. And it comes with a system called the Smart Launcher. So this lives at launch.smarthealthit.org. And this is just a very flexible tool if you're getting started building a smart app that you can use to integrate your app with kind of a mock EHR. You can test all of the various launch flows that we've talked about. So if you're building an app that's supposed to integrate into the EHR with the EHR launch, you can select that launch type, and you can configure a few other details, like maybe your app works on pediatric patients only. So you can pre-select a set of pediatric patients, and you can say, only prompt the user to choose from this limited set of patients so that users don't accidentally run your app on records where it's not really a good fit. And then you tell the launcher, here's where my app lives. Here's the launch URL. And then you can click this launch button. And you'll see your app integrated into the context of a very simple mock EHR. Here I'm going to click Launch Sample App, so you can see kind of a very basic developer-oriented app and kind of how it integrates into this launcher environment. But let me actually skip ahead a little bit, and I want to show you what it looks like to use this tool as an app developer in a very simple, standalone programming environment. So if folks haven't seen glitch.com before, it's just a very cute standalone environment where you can build a web application using many different software tools or architectures. In this example, I'm just writing a basic HTML5 and JavaScript app, but you can also use this environment to run kind of server-side code as well. And I want to show you kind of the anatomy of a smart app. And before I do, let me just kind of show you what it looks like to run this app. So you'll know what we're building towards. I'm going to open this in a new tab so you can see what's going on. And this app is designed as kind of a demo, so it can show you what it looks like as a standalone launch or what it looks like when launched using our Smart App Launcher. So just to start here, I'll say, in the context of the Smart Launcher, you can pick your app, you can pick a sample patient. I did a bad job by picking one with no glucose readings. And this is an app that's all about glucose readings. And the app in this case is able to fetch a set of FHIR observations and just sort of plot them on a time graph of glucose values. But under the hood, what is happening? So this application, we just looked at the standalone launch, and it's using a library that we make available through Smart called the FHIR Client Library. This is one of many libraries that are available for working with Smart on FHIR, but it's a convenient one because it works for browser-based apps like this example. And what the standalone page does is it just calls this authorize function. It tells the client library, hey, I want to authorize against this endpoint from the Smart App Launcher. So this is like the EHR you want to connect to. It says, what scopes of access do I want to get? And when I'm done launching, what page should be opened? That's called the redirect URI at the end of the OAuth flow. And so when I click approve and launch that app, this page that opens is the graph.html page. And this one is responsible for fetching the data and making a plot. And I won't go through this in great detail, but you can get the sense that what the app is doing on this graph page is it's first making sure that we're ready. So it calls the OAuth 2 ready function of the client library. And after it does that, it has access to smart.patient.request, where it can issue FHIR calls about the patient who's currently in context. So this is a FHIR REST API call that says, I want to get all the observations with this LOINC code for glucose, and I would like them in descending order by date. So give me the most recent ones first, and I want up to 10 different values that I can plot. And then it just parses the data out of that FHIR response, and it uses a plotting library to draw them on the screen. So an app like this is something you can build in kind of 100 lines of code just to get the idea of completing an authorization flow and launching that connection. We're at time? Oh, I've got 36 minutes, but maybe my clock is off. Yeah, okay, cool, yeah. So we've been doing some inline questions. So I was going to count that against my total. But let's just say, let me make a quick point about sandboxes here before we wrap up. So I've shown you the Smart on FHIR sandbox. There are many sandboxes from EHR vendors that are worth connecting to early. And you'll find that the specifications, particularly data profiles like US Core, often have options. You can represent a medication with just a code saying what the drug is, or with a link to a medication resource. And those are both allowed by the underlying specification. But you'll find that different vendors take different choices there. And so if you're building an app and you've only ever tested against one of these environments, you might find that your app just crashes when you try to connect somewhere else. So connecting to many different environments early will give you a sense of what are those points of optionality, and that will help you make your app more robust. So there's a few sandboxes listed on this slide, but in the US context, there's also a national government site that lists every certified EHR and their developer documentation in kind of one central place. So that's the quick overview. Let me pause here and once again put in a plug for feedback. Would love to get a sense of how we can tailor this presentation moving forward. If you've got time, please do share. And now let me open up for questions, whether it's in the room or folks online.
Thanks, Josh, for the presentation. So one thing that, when I was working with version 1 scopes, one of the issues was that it seemed that, it's not very flexible to specify what the user is authorized to access. And I saw that, in version 2, you're saying that, you're adding support for search parameters, which is great. So the question is, two related questions is that, so is it supposed to support everything in search? Like, if I say observation, then like, every feature that search can have, like chaining, reverse chaining, whatever. Is it that wide? And how much is the support, how much this V2 version is being adopted? So what is the support on, like, for example, that Smart Sandbox that you mentioned, does it support it?
Yeah, so great question about scopes in Smart V2. What we tried to do was define a language for scopes that would be as broadly useful as possible, And so in our specification, let me just find the little railroad diagram here. This is sort of what scopes look like. It's one of these access levels, plus a resource type, plus create, read, update, delete, search, and then some set of parameters and values. Now this language is pretty broad. You can use it to say a lot of things, some of which are fairly easy for an EHR to implement, and some of which are very complex for an EHR to implement. So what we say in the specification is, let me just grab the right language here. We're looking for consensus on what are the kind of common core capabilities that are most useful in these scopes. And my guess is that profiles like FHIR US Core will begin to publish scopes and say a server needs to be able to support observations by category. So I think we'll grow out kind of a small set of expressions rather than expecting servers to be able to somehow manage every possible statement in this language. But we wanted to have a consistent language so we don't have to go back to the drawing board each time there's a new use case. We also do highlight a few of these things as explicitly experimental, things that we have reason to believe are hard to implement in real life. And so we call out things like chaining as experimental. We call out modifiers like code:in, and we call out the FHIR_filter. These are things that you probably shouldn't expect are going to work, but they do have an interpretation in this language. What's that? So on the adoption front, I think that the core focus for early adopters of Smart v2 is on this translation layer, so that the scopes that already existed in v1 can also be expressed in v2. We define this kind of mapping. And I think that's kind of what you should expect is going to be available early on, and then we'll see more nuance over time. I think that in part that will be driven by regulations requiring that level of specificity. Awesome. Other questions?
Hey, right here. I was just curious, are the data providers limited to EHRs only, or can anything with a FHIR endpoint register?
Yeah, so anything with a FHIR endpoint is the goal. And that kind of goes back to this initial slide where we said, yes, some of these are EHRs, but they may be research data systems, they may be other kinds of data warehouses. Anything that has FHIR data should be in scope here. Other questions? There's one or two in front.
Hello, Josh. I'm a user of the Smart on FHIR Python library, actually, and I would like to know how continually it will be maintained with the new FHIR versions, and are there any, plans on include new data models with the new FHIR versions as well? Yeah,
so FHIR Python library. One of the earliest libraries that was actually published initially by Pascal Pfeffner, who's now working at Apple. This is a library in search of maintainers. So we've had some community contributions over the course of the last couple of years who have just sort of kept things patched together. But if you're interested, this is just a general call, in taking on responsibility or ownership for these libraries, I think there's a few things we've learned, particularly since 2019 or 2020, that could help in managing and maintaining a library like this over time. So definitely reach out. There's a Python channel on chat.phir.org, and we'd love to figure out whether there's somebody who might be willing to step up there.
Hi, I have another one on scopes. How do you see FHIR operations being part of that?
Yeah, so what we say right now is we don't have an explicit language in our scopes syntax for calling operations. We spent a while thinking about what that could look like over the course of the design phase for Smart v2, and it was complicated because operations can do very different things, and then they can do different things depending on what parameters you pass in. So I think if folks are interested in modeling operations, it's good to bring ideas to the table. The scope language right now is open-ended, so we have a few extensibility points that you can use to say new things. But operations are going to be tricky. You probably want a way to say, I want permission to call this operation with a specific parameter pre-bound. So maybe I'm only going to be able to call this with certain parameters fixed in place and other parameters variable. We didn't try to go that far in our current publication, but I think it will take that level of detail to get it right. We have time for one more question. Anyone? Oh, one all the way in the back.
I'm curious what you think about FHIR right and the complexity there for healthcare organizations to support it, and if there's standards, similar to, vein of Smart or HL7 that will assist that.
Yeah, so from the perspective of writing data back into an EHR, the Smart spec thinks it's perfectly simple. You just get access to a scope that lets you write, and then you do FHIR CRUD operations that put or update or delete data. Problem solved. In real life, there's a lot of organizational policies and reasons why that is hard. But I don't know that they're about sort of the OAuth flow and the connectivity. So there's a couple directions that I think are promising here. One is some projects that are focused on really narrow use cases. So in the Argonaut Standards Accelerator this year, we have a project focused on apps that can write vital signs back to the EHR in the context of a clinician setting. So maybe a clinician is viewing data that a patient recorded at home from their blood pressure cuff, and they say, I want to bring this set of results into the EHR. And when you apply that many constraints, it gets easier to enable by policy. And then the other technique, which I think is promising, is what I'll call pseudo-writes. So in a specification like CDS hooks or smart web messaging, you can have an app that basically sends back to the EHR some data that it would like written. And it's not like saying, I just created this data, but it's sort of propagating into the EHR and information that the end user might then review and incorporate back into the EHR. And so that might also be kind of an interesting component of the mix here. But I think it's going to take more creativity and exploration to see what sticks. Some folks are thinking about holding tanks. So you can write, but it's only being written to this holding tank, and later somebody has to come by and fish out the right elements. That's another idea. Anyways, all right. Thanks, everybody, for the attention. Come grab me. I'm here all week if you want to talk about other things that we didn't have time for today. I appreciate it.